Welcome to the DIY Honda Garage channel. DTC P26E6 stands for Starter Cut Relay 2 Control Circuit High Voltage. This diagnostic trouble code indicates a malfunction in the Starter Cut Relay 2 system of the 2022 Honda Civic. The starter cut relay is a crucial component that prevents the starter motor from engaging until certain conditions are met, such as verifying that the vehicle is in park or neutral. When the engine is turned to the on position, the Powertrain Control Module, PCM, monitors the return signal from this relay. If the signal is abnormally high when the starter is activated, the PCM recognizes this discrepancy as a fault and stores the DTC for further examination. Addressing this fault is essential for ensuring the proper starting function of your Honda Civic. The Starter Cut Relay 2 is designed to facilitate the starter motor's operation by only allowing it to engage under specific conditions. Its primary role is to receive and send voltage signals that indicate whether the vehicle can safely start. Located within the relay circuit board, this component directly interacts with the Powertrain Control Module, PCM, which is responsible for maintaining optimal engine performance. During normal operation, the PCM continuously monitors the return signal from the Starter Cut Relay 2. If this signal becomes excessively high, indicating a potential fault, the PCM triggers the DTC P26E6. Recognizing the importance of this relay in the starting process helps in understanding why this malfunction directly affects your vehicle's ability to start successfully. Multiple factors could contribute to the appearance of DTC P26E6 in your Honda Civic. One common cause is a shorted wire within the circuit, which may lead to incorrect voltage readings being sent to the PCM. A shorted wire means that the electrical current finds an unintended path and can disrupt the communications necessary for the starter cut relay to function correctly. Another potential cause is a malfunctioning Powertrain Control Module, PCM. If the PCM itself is defective or not processing the signals accurately, it can erroneously interpret normal conditions as faults. Finally, an issue within the relay circuit board itself can lead to abnormal voltage levels and trigger this DTC. Diagnosing these causes requires careful inspection of the related wiring and components. Owners experiencing DTC P26E6 may notice several symptoms while driving their Honda Civic. The most prominent symptom is a failure to start the engine, which can be frustrating. This occurs because the starter cut relay is either not receiving the correct signals or is unable to engage the starter motor. Additionally, there may be abnormal operations of the relay, such as erratic behavior or unexpected clicks when attempting to start the vehicle. The PCM will also store this trouble code, which can be accessed through diagnostic tools. Understanding these symptoms can help in accurately diagnosing the underlying issues related to the Starter Cut Relay 2. The first step in troubleshooting DTC P26E6 involves attempting to start the engine. This step is crucial as it allows the technician to observe whether the engine responds or not. While starting, pay attention to any unusual sounds or activities from the relay, such as clicking that does not follow the expected pattern. Following this attempt, use diagnostic tools to check for stored error codes. The data gathered will provide initial insights into the vehicle's electronic systems and can highlight the specific malfunction leading to this DTC. Observing relay operations during this process can also shed light on any abnormal behavior that may further indicate the source of the issue. The second troubleshooting step involves disconnecting several crucial components to systematically assess the potential fault. Begin by disconnecting the Powertrain Control Module, PCM, connector. This is a vital step as it will allow for a thorough inspection of the PCM's internal operations without external interference. Next, disconnect the relay circuit board to evaluate its condition independently. Following these disconnections, conduct visual inspections of the connectors and wires for any signs of wear, damage, or corrosion. These inspections can help identify issues that may not be evident during initial diagnostics and are essential for avoiding false diagnoses. In this step, conduct a wire integrity test to confirm the soundness of the circuit wiring associated with the starter cut relay. This involves checking each wire for breaks, shorts, or exposed areas that may lead to improper voltage readings. A short is a significant concern as it can send erroneous readings back to the PCM. Use multimeter tools to measure continuity throughout the circuit. Continuity tests will verify that there are no gaps in the wiring that would prevent signals from reaching their intended destinations. Address any issues found during this testing before moving on to the next steps in the troubleshooting process. In the fourth troubleshooting step, confirm that signal conditions are appropriate when the starter cut relay 2 is activated. This includes ensuring the correct voltage is reaching the relay. Reference the diagnostic data that comes from your testing to establish a clear understanding of the expected operational parameters. Cross-check these readings against manufacturer specifications. If the signals remain abnormal, evaluate the functionality of the PCM. A malfunctioning PCM may misinterpret the signals it receives. Any irregularities will provide clues toward whether the PCM needs repair or replacement to resolve the DTC P26E6. Once repairs have been completed for DTC P26E6, it's essential to verify that the problem has been successfully resolved. Begin by clearing the Diagnostic Trouble Code, DTC, from the Powertrain Control Module, PCM. This process resets the system and allows for fresh evaluations. After clearing the DTC, test to see if the engine starts correctly. If it can, this indicates that the repairs were successful. However, it still requires rechecking all connections made during the troubleshooting and repair process. Ensuring that all wiring and connectors are secure can help prevent future issues from arising. Preventive maintenance is essential for ensuring the longevity and reliability of components like the starter cut relay in your Honda Civic. Regularly inspect all electrical connections related to the starter system, looking for signs of corrosion or wear that could lead to future failures. Monitoring system performance can also help identify subtle changes before they evolve into significant issues. If early warning signs are observed by the vehicle's diagnostic system, addressing these promptly can prevent the recurrence of DTC P26E6. Routine maintenance not only extends the life of your vehicle, but can save you time and money on repairs. In conclusion, understanding DTC P26E6, which signifies a high voltage issue in the starter cut relay 2 control circuit, is critical for Honda Civic 2022 Plus owners. Systematic troubleshooting involves determining if the starter system or its related components are faulty. Following the outlined steps for diagnostics helps ensure all potential faults are addressed effectively. Regular preventive maintenance is key to spotting issues early and prolonging the longevity of your vehicle. Ultimately, staying informed about your vehicle's systems will enhance both safety and performance while minimizing costly repairs. Please like and subscribe to the channel. See you next time!